See better next one. Oh, see if some mass of area is removed, if some mass of area is removed from a rigid body, then the position of center of mass of the remaining portion, center of mass of the remaining portion is obtained by, first one, if it is RCM, RCM is equals to your M1 R1 bar removed kabatti minus M2 into R2 bar divided by total mass, M1 minus of your M2. Okay na?
Yes.
XCM, XCM is equals to your M1 X1 minus of your M2 X2 divided by your M1 minus of your M2. Same way YCM, YCM is equals to your M1 Y1 minus of your M2 Y2 divided by your M1 minus of your M2. In the same way ZCM, ZCM is equals to your M1 into Z1 minus of your M2 into Z2 divided by your M1 minus of your M2 part of it. Okay, M1 R1 X1 Y1 Z1 are nothing but what are values of the whole masses,
Yes.
and M2 and X2 are nothing but what are all the values which have been removed. Okay, X1
Yes.
R1 X1 Y1 Z1 are initial masses,
And
R2 X2 Y2 and
are
Z2
the
will be
removed masses.
the value of the masses which has been removed from the given
Removed.
condition.
Yes.
Okay na? So
Yes,
in the
sir.
same way, write the next point in this one today. For a two-dimension body, for a two-dimensional body, for a two-dimensional body with uniform negligible thickness, okay, for finding center of mass, it becomes center of mass formula. RCM bar will be equal to, what is the formula? M1 R1 bar plus of your M2 R2 bar so on up to large number divided by mass kada, M1 plus M2 plus so on up to large number.
Yes, sir. Yes, sir.
For two-dimension body, what we do is, in the place of mass, we'll be writing in terms of thickness. Mass is equals to, we know the relation, mass is equals to volume into thickness. Volume into your thickness. Okay, na? Volume is equals to what, beta? Volume is equals, mass is equals to volume into, so mass is equals to volume into density, kada? Mass is equals to
Yes.
volume into density. Volume into density. Mass is volume is equals to what? Area into thickness. A into T into rho. So this will be the mass. Okay, na?
Yes.
Of area in terms of thickness and in terms of your density. That means this formula will become for me RCM bar is equals to, this will become for me rho into your density of the metal will be remaining same kapati. Area of cross section whatever you remove, that is A1 into thickness T into your R1 bar, plus this will become for me how much for me? Rho into area of this one is A2 thickness T into your R2 plus so on up to your large number divided by total mass. Total mass will be equal to rho into A1 into T plus of your rho into your A2 into T. In the thickness is negligible. So thickness ni T same. So if I'm writing that formula right now for here, RCM will be equal to rho get cancelled everywhere, and T and T will also get cancelled everywhere. So this will become for me A1 into your R1 plus of your A2 into your R2 divided by your, this will become for me how much beta? A1 plus of your A2. What is A stands here beta? A is nothing but what? Area. Clear?
Yes, sir.
So what is getting cancelled in this one? This row, this thickness, row,
Row,
and
thickness. Yes, sir.
this is your condition. Is it clear?
Yes, sir.
Isn't it? So for any regular bodies part affiliations, this is the basic relation you need to remember for the given conditions. I hope you got an idea.
Yes, sir.
Teacher. కాలేజ్ ఎక్కడ వరకు అయిందన్న?
Sir, center of mass later we did till path of center of mass, sir. Means
Okay.
that hyperbola.
Okay, the path followed by that one when you said.
Yes, sir. Yes, sir.
Okay, fine. మెటల్ చేస్తున్నావు కంప్లీట్ గా?
Yes, sir. College lo kuda we like in vertical circular motion we finished with the workbook process, sir.
Okay, okay, fine.
And path
So
of
the next
center of
heading.
mass we didn't do the whole thing, sir.
Okay. Center of mass of your bodies. Center of mass of bodies of continuous mass distribution. Continuous mass distribution. Center of mass of the bodies of your continuous mass distribution. Okay, first one. I told you this one already in, so what do you call that one? Laws of motion. First one is linear mass density. First one is linear mass density represented by lambda. So lambda is equals to how much beta? Dm by your dl. Unit is for this one kg per meter, isn't it? Areal mass density. Next one. Areal mass density. Areal mass density represented by letter sigma. So sigma is equals to your dm divided by your dA. Unit is kg per meter square. This is for your 1D. This is for your 2D. Okay. And the third one is volume mass density. Volume mass density represented by rho. This is for your 3 dimensions. So rho is equals to mass per your unit volume, that is dV. So unit for this one is kg per your meter. Okay. So when we are talking about continuous body, we use integration. We use integration to calculate center of mass. Okay. So how do we do that one? XCM is equals to integral of your dm into your x divided by integral of your dm. The same way YCM will be equal to your integral of your dm into your y divided by integral of your dm. The same way ZCM is equals to integral of dm into your z divided by integral of your dm. That means we'll try to take a small part of your regular body and we take the help of your integration and try to simplify the position. In the same way, if I am talking about for position vector in calculus method, position vector in calculus method ala rastamu, RCM bar will be equal to integral of your dm into your r bar divided by integral of your d. Is it clear?
Yes, sir.
So we use the integration method to calculate the center of mass either in x-axis or either in your y-axis or either in your z-axis part relation. Position vector formula general HSC basically. Okay, let me
Yes,
give
sir.
you one small example. Continuous bodies ante like see, locate center of mass of rod of length L with uniform distribution of mass, with uniform distribution of mass. ఓకేనా, అంటే మాస్ ఇట్లా ఉందనుకో యూనిఫామ్. ఓకే, అండ్ దిస్ ఈస్ kept on your y-axis. ఇది y-axis ఉంది, and this one is kept on your x-axis like this. Okay, this one is your A and this one is your B. ఇది rod. Okay, this is your uniform rod part deflection. Mass is uniformly distributed from this one. Now how do you do such type of a problems? You see beta, what we need to do is analysis. Should how do you are using this one? Is a continuous body kabatti, every time whenever you are doing like that, you take one small element of this rod, din mass dm anukundam, din width dx anukundam, and this distance from the origin is x anukundam. Is it clear?
Yes, sir.
Isn't it? So now what is dm right now? dm is equals to lambda is equals to dm by your dx and raskovacha, linear mass kabatti.
Yes, sir.
So dm will be equal to how much beta? Lambda into dx and raskovacha. Total length is how much for me? 0 to ఇది L అనుకుందాం, capital L small l whatever it may be. So xcm will become how much for me? xcm is equals to integral of your dm into your x divided by integral of dm. Length ఎంత ఇచ్చాడు నాన్న మనకు? 0 to L ఇచ్చాడు కదా. Total length of the rod is given as L.
Yes.
It will be 0 to your L. This one is also your 0 to your L. అంతేనా? So now just substitute that values there right now. Integral of your dm value is how much for me? Lambda into dx into your x. Limit is 0 to your L divided by dm is nothing but integral of this one. Lambda into your dx. Limit is 0 to your L. So in this one, lambda is out. This one is integral of your x into your dx. Limit is 0 to your L divided by. This one is lambda out. Integral of your dx. Limit is 0 to your L. ఇప్పుడు చూడు దీని క్యాలిక్యులేషన్ చేయ ఎంత వస్తుంది? సో దట్ విల్ బి ఈక్వల్ టు యువర్ ఎంత వస్తుంది చెప్పు? లాంబ్డా అవుట్ ఇంటిగ్రల్ ఆఫ్ x into dx is how much beta? x square by 2 limit 0 to your L divided by this is L. Integral of dx is nothing but of your x. Limit is 0 to your L. Substitute upper limit minus lower limit. It is lambda into x square divided by, in the place of x, upper limit L. L square divided by 2 divided by lambda into this one is also L. Anything is getting cancelled in this one too? And this one and this one will get cancelled. Yes. Square and length will get cancelled. So I'm getting the answer is equal to how much for me? L by 2. So yes. Center of mass of this one for a rod will lie where beta? Exactly at the center. That we got proof here also. It is exactly a distance of how much for me? L by 2. Achinda?
Yes.
Okay, so we'll do more applications of this one in the tomorrow session of a class. Okay.
Okay.
Okay. Bye beta.
Thank you, sir.